Hi, students in the Netherlands. I'm Kevin Czajkowski. I'm a professor at the University of Toledo in the Department of Geography and Planning. And I also work on the urban heat island intensive observation period for the GLOBE program. Matthias and Esther asked me to make a little video for you. So introducing you to the observation period. So I'm going to share my screen. Talk about the urban heat island effect. And you may or may not know this, areas in urban areas tend to be warmer than the rural areas around them. In this case, you can see how the downtown area of the city is about 34 degrees Celsius. And maybe out in the countryside, it's 29 degrees Celsius. So quite a big range. And we see that all over the earth, all over the world, where there's this big change between urban areas and rural areas, a lot warmer in the urban areas. And some of the reasons we care about it, the energy consumption increases during heat waves and also because of this urban heat island. Air pollutants become worse, such as ozone, which is a pollutant that hurts people's lungs or also affects plants. And then also people may die during a heat wave in the urban area due to excessive heat. I wanted to show you this website by Midstory. They did a story map about urban heat island in Toledo, and I think it's very interesting to look at. So here's the URL if you want to take a look at it. And I'll show you a few things my students have done, especially this summer. And this student, Ornan, she is from Thailand. She was visiting from Thailand. And she looked at the University of Toledo and the neighborhoods around it. So she made like a quadrant, 9 of them. And on the left here, this is the temperature. You can see how the red here. In the center is the University of Toledo. Blue is cooler. And then this is the vegetation, the NDVI, Normalized Difference Vegetation Index. More dark green means more vegetation, white means less vegetation. Now what we found is that in the center at the University of Toledo, that's the hottest temperature in the area and the lowest vegetation. Whereas some of the areas around it have higher vegetation and then lower temperature. See how there's a nice relationship between the two. I'm pointing out the University of Toledo and then the parks. My students have used GLOBE data to look at the University of Toledo. You can see all the different observations. This was last fall, and I'll probably do the same thing this fall. And the orange is hotter, green and blues are cooler. And you see that some of the hottest temperatures are the football stadium. This is American football. And then this is the soccer stadium. That's another hot spot. And that's, of course, international football. And both of these are artificial turf fields. So it's not grass. Now this yellow here, this is a grassy field. You can see how it's cooler than the artificial turf. And what we found is that the University of Toledo is one of the warmest places in the city of Toledo. And partly also because of this artificial turf. I did want to give you some pictures. This is outside my office. You can see how it is urban. There's a lot of cars and parking lots. And look how big that parking lot is. It doesn't have a lot of cars in it right now, but when school starts next week, it'll have a lot of cars in it. The football stadium is right behind that. It's the American football stadium. And the international football stadium, or the soccer one's over here on the left. And I wanted to show you how the parking lots are very black. So the albedo is very low. It absorbs sunlight and then gets very warm up to, maybe 40 or 50 degrees Celsius. Now the intensive field period is going to be in October, December, and March. My understanding is you're going to do this in September, and that's great. I think it's a wonder. Any time of the year is wonderful. And just a little bit about the surface temperature. We're going to do surface temperature, air temperature, and clouds as the observations. That's what I like to do for urban heat island. And why do you do that? Well, the sun heats the ground up, and that's the surface. So like the vegetation on the surface or pavement, buildings. And then the energy from the surface goes into either evapotranspiration, so that's evaporating water from the surface or for plants. It goes into sensible heat, which is the air temperature we feel, and that's why we do an air temperature observation as well. And then some of the energy is emitted to space as electromagnetic energy, and that's the energy that cools the Earth. It's in balance with the sun. Also, that's the energy that the greenhouse gases absorb. So if we add more greenhouse gases to the atmosphere, it absorbs that emitted long-wave radiation, which then some of it is emitted towards the ground, keeping the Earth warmer. This is how I want you to point the infrared thermometer at the ground, kind of perpendicular. Push the button, then let go, and then make the reading. And I just had a summer student this year, Will. He looked at paving surfaces. And I know Europe has these pavers similar to this, where it has grout in between. And he wanted to look at that versus asphalt, oil and chip, or these pavers here. And this is the data he took using an infrared thermometer. You notice on some days when it's warmer, the range is higher, and that's what we wanted to show with the standard deviation here. And then on cooler days, the range is lower, and that's generally a cloudy day. And looking at the averages, asphalt's the warmest in Celsius, and the terracotta brick or permeable pavers are the coolest. The nice thing about these is also water can infiltrate through the cracks between the bricks. So they do two things: they keep down flooding, reduce flooding, and then they also reduce the temperature. So if you have a chance, take globe observations as part of this Urban Heat Island campaign, intensive observation period, and then do a project for the virtual science symposium for Globe. Those are usually due on March 10th, those projects, and projects related to Urban Heat Island would be great. All right, I want to thank you for your attention, and I hope you have a great time doing the observations and a good school year.